You're listening to Impulse to Innovation. The Institution of Mechanical Engineers podcast. I'm your host, Dr. Helen Mees. As a global community of mechanical engineers with over 120,000 members in 140 countries, the Institution of Mechanical Engineers has been at the heart of the engineering profession since 1847. The institution's mission is to improve the world through engineering by sharing the latest news, views, and insight into the creative world of technology and the people that make it happen. As the Olympics fast approaches, summertime temperatures will only continue to get hotter, giving athletes additional challenges as they seek to bring home medals. With Paris 2024 taking place in the host city's hottest month of the year, leading athletes are already warning that intense heat could lead to competitors collapsing and, in worst-case scenarios, dying during the Games. What role can engineering play in ensuring athletes, officials and volunteers, and those just watching the Games, stay cool in and around the various sporting venues? My guests this month are Ruth Shilston and Professor Mike Tipton. They share their thoughts on the potential heat risks facing the Olympics this year and in future years in light of growing global temperatures, and how engineers are designing devices and building facilities to mitigate the effects of heat. Ruth Shilston is a Fellow of the IMechE and a current trustee and Technical Director of Engineering Sciences at Mott MacDonald. She has been a leading specialist on the engineering of major construction projects worldwide and is a subject matter expert in human thermal comfort and climate-aware design, as well as author of numerous industry guidelines, technical and policy papers on heat adaptation and construction. Ruth, thank you so much for coming on the show today. It's a pleasure to have you on the podcast.
Oh, I'm really excited to be here, Helen. This is one of my favourite topics to talk about.
Excellent. Well, I know that your interest is in comfort and safety of venues and particularly the thermal comfort. So what does thermal comfort mean?
So as human beings, we're amazing. We have these really complex mechanisms that allow us to control our temperature. So when it's very cold, we shiver. And then when it's very, very hot, we sweat. Very, very different approaches to keeping us at the temperature our body needs to be at. And in engineering terms, that's all about fluids and thermodynamics.
Yeah.
Some part of my job is around creating the right fluids and thermodynamics for us as people, be that in an office or walking around a city. I think athletes, sports people are probably one of the biggest challenge because, again, what they do is incredible. They are pushing their bodies to the absolute limit of what they can do, of what we can do as human beings. They're running the fastest, jumping the highest, really tuning themselves. And when we think about thermal comfort for sports venues, for athletes, we don't really refer to it as comfort. We actually refer to it more as heat stress.
Okay.
So it's very much around creating an environment so that these humans who are pushing themselves to the limit don't tip over that limit, don't make themselves sick or unwell. When we think about athletes, we're very much at that hot end of the spectrum. So when we do a huge amount of exercise, when we're running, you'll have experienced it. You sweat, right? You push water out your body and that water evaporates, and that evaporation process takes energy, which helps to keep you cool.
Yeah.
And your ability to stay cool, stay at the right temperature, it is dependent on what the air temperature is. And we all know the weather forecast tells us it's 20 degrees outside. But when we think about athletes or anyone doing hard work, a person working in a manual labour, it's that sweating that's really, really important. So what I'm interested in as an engineer is the air temperature, but I'm more interested actually in what the humidity is in the environment you're in and how much air movement there is around that person, because our ability to sweat, it's not a particularly nice thing to think about, is actually really dependent on how much moisture there is already in the air. If it's very, very humid, then our sweating is very inefficient.
Right.
And then again, how much air is moving across us, be that wind, sort of natural convection or forced convection from a fan or from air conditioning. And having air move across us, it takes that moisture away and it replaces it hopefully with air that's less humid, which allows us again to sweat really, really, really effectively. When we design buildings or sports venues, the measure that we use for this heat stress is something called wet bulb globe temperature.
Yeah.
And it's a measurement that's used by a number of the sporting regulatory bodies. And it's a measure that was developed actually for the military, so they could understand again whether it was safe to put their troops on patrol when they were training them. And it really looks at that humidity and air movement piece. What's really great about the wet bulb globe temperature is that you can buy a device and go out into a sports venue and actually measure it. So it's a physical handheld device that allows measurement in situ instantaneously to make a decision of whether it's safe, whether it's thermodynamically safe for a sport to take place. But also it has an equation behind it. So as an engineer, I can simulate my stadium in a computer, and I can predict how a particular environment's going to perform on a particular day or particular climate.
So we're not just talking about engineering, but we're talking about physiology, we're talking about the environment that we're in as well. So this is bringing lots of different sorts of science and engineering to bear on how we can make sure that people are safe in these environments.
Yeah, absolutely. And it's also really about understanding weather and climate. So if I think of a sports venue such as a velodrome is an indoor environment. And as engineers, we create a very, very controlled environment because in that case, actually even something as simple as the density of the air, which is impacted by temperature, that affects how fast those cyclists can cycle. But it's a very, very controlled environment. We've created a building that's largely sealed and we're air conditioning it. And I as an engineer, can design that to have very, very, very close control. When we think of the Olympic Stadium, and we're sort of talking about the Olympics here, they're always open air venues. And the majority of the sport that we play is in the open air. And that's how we like to play sports. And there's a number of sports where that's actually still sort of baked into their requirements. And that's much more complicated because we all know how hard it is to predict the weather. Mm-hmm. A huge part of my job is getting climate data and really understanding for a particular location. So Paris this year, what is the likely climate? So statistics come into it as well. Statistically, in July, is Paris likely to be hot? Is it likely to be humid? What are the wind speeds likely to be? And what combination of those? Because it's actually the combination that's really important.
Yeah, well, you touched on climate there, and I think that's a really important point to make. It's clear to all of us that climate change is now having a global impact on society. And in April of 2023, the IMechE published its Adapting Industry to Heat report. But much of what was said in that report could easily be applied to the sports sector. What do you think can be learned from that report in terms of taking that information about manufacturing and playing it across the sports sector?
So that was a really interesting report. As you mentioned, it was really focused on industrial facilities, and they're very interesting because not only do they have human beings working and often doing quite manual labour, but we also have a number of industrial processes that, again, need to happen at a very specific temperature and humidity. So if we don't adapt those facilities to climate change, then we won't actually be able to do the process to make the food or the chemical that we need as humans. Yeah. What the report highlighted was a real challenge. We have two challenges facing us as humans. We need to reduce our impact on the environment. So that means using less energy, ideally less air conditioning if we're talking about buildings, looking at ways that we can be much more considered, sustainable in how we act. But at the same time, we have to adapt to a climate that's changing. So the simple answer would be, closely control our environment, put more air conditioning in. But we can't do that because we have to reduce our impact. So we're asking buildings across the world, for all types of buildings, to solve both of those challenges at the same time. And that's incredibly difficult.
Yeah.
If we think again about the topic of thermal stress, one of the things this report talked about was not only just on those industrial facilities, but on the wider environment that we create for workers. And it's the same for our athletes. So I talked a little bit about design of stadia or other sports venues. That is where that athlete has to perform, be that in a sprint, 100 meters, 10 seconds, you're done, or you might be running several kilometers or playing a 90-minute football match. But the place where those athletes live and sleep is equally as important. So we could create the perfect sports venue and we could focus all our energy and say, well, we'll use a bit of energy just to make that sports venue really, really good. But if the athlete's village is too hot or too humid, then those athletes aren't going to sleep, or they aren't going to have an environment that allows them to recover sufficiently to give them that sort of ability to cope with the hotter environment somewhere else. And we've already seen that in Paris, actually. Paris was aiming to be a no air conditioning Olympic Games. Yeah. They had a real push on being the greenest games, which all credit to them for that. But we're seeing reports now of some nations are looking to retrofit air conditioning into the athletes' accommodation to provide that respite for their athletes, or to provide certainty to lower the risk, which I think is quite interesting, because one of the things about sport is that as athletes, it's your job to push yourself to the limit. Mm-hmm. And as a nation running a team, or as a sports governing body, it's their job to protect those athletes, to allow them to do that, to push themselves to the limit. And I have a couple of actual examples, moving away from the industry report, but some examples of how we look after our athletes. Football is governed by FIFA, and they have a very strict heat stress policy. It's really well thought through, it's really well implemented, and they say that there's a high risk of heat stress when that wet bulb globe temperature goes above 29.4 degrees Celsius.
All right.
So wet bulb globe temperature gives us an output in degrees Celsius. And at that temperature, instead of playing a match in 2 halves, you have a match in 4 quarters. Oh, okay. So you bring in extra rest breaks, and you allow your athletes to spend time, or your footballers to spend time rehydrating. So you have an extra break that's longer than the 2 minutes they could have otherwise, that allows them to potentially sit somewhere that's air conditioned and cooler, but most importantly, take on fluids so they can replace all the fluids they've lost by sweating. And in the Beijing Olympics in 2008, they implemented that in the football final, because Beijing reportedly got up to 34 degrees C, wet bulb globe temperature. So they did that in Beijing to protect those athletes. On the flip side, tennis has a less rigorous heat stress policy. And there are reports across the tennis world, particularly from the Australian Open. But in Tokyo, there were various reports of athletes being sick or passing out. And actually, Spain's Paula Barbosa retired mid-match because she couldn't cope with the heat, and she had to be taken off court in a wheelchair. But it's a real challenge for those athletes, because by doing so, she forfeited the match. So in effect, she didn't do her job, and there was an environment that wasn't created to allow that job to happen. You can almost think of athletes like workers, albeit doing an exceedingly unique role or exceedingly unique job. Yeah.
And I'm guessing that the situation for Paralympians has to be looked at in a completely different way as well. They are going to need to have an environment that is different perhaps to an able-bodied person. So your setup within their rooms, their accommodation, and as well in the stadium is going to be different as well to cope with the heat, right?
Absolutely. Your later speaker might have more knowledge on this, but it's my understanding that when people have limbs removed for whatever reason, it takes quite a long time for your body to adapt to that thermodynamically. So persons who've had amputations for whatever reason, the facilities where they do their rehabilitation to adapt to their amputation, they have to have very specific temperature controls, because those people will be too hot or too cold because their body just has less surface area.
Yeah.
And you've suddenly got less surface area. It's not like it's adapted over time. You've gone from having a leg to not having a leg, and its surface area is a huge part, again, of our ability to thermodynamically interact with our environment, be that by conducting into the air that convects away, or through your sweat surface.
Yeah. So thinking on that in terms of the needs of those athletes, what kind of technologies are being used to address heat and thermal comfort in stadia, and how might this benefit athletes competing in such hot climates as we're sort of going forward into the next Olympics?
It's a real challenge, and there are a number of different ways forward. So we saw with Qatar 2022, obviously that was a football event, and Qatar is a naturally hot country, irrespective of climate change. And there were 2 things that happened there. One, the event was moved to winter when it's cooler. Yeah. So we think of the Olympics as a summer games, and it is a summer games. But when it's in Australia, actually it's a winter games because that's their winter. So when we're in the southern hemisphere, it is a winter games. So one thing I think we can do, it's not technology, is we can shift the schedule. We can both shift the schedule by actually which weeks of the year the event happens, but also shift the schedule in terms of the time of day when the sport takes place. So in Tokyo, they did the swimming very, very early in the morning before it got hot. Because I think this was for the outdoor swimming, the sort of lake swimming. Even the water heats up over time, not as much as the air due to its density, but to protect the swimmers, they did swimming very, very early in the morning in Tokyo and scheduling at different times. Not having sport at 3 o'clock in the afternoon when the sun is directly overhead is very, very key. And the other approach that Qatar took was obviously to air condition their stadia, which it was hugely controversial. It was a project that I was very actively involved in. So it was done to provide the minimum cooling required. But in order to host that event in that climate, it had to be air conditioned, which comes back to that conversation of, how do we reduce our impact on the planet whilst achieving sporting greatness? In terms of technology, I think as engineers, and I often find that in my industry, people say, well, what's the clever technology you've come up with to fix this problem? And I think actually we've been designing buildings as humans for millions of years, right? We, as humans, as I said at the beginning, we're very clever. Our bodies are very clever at adapting to heat through shivering and sweating and conducting and convecting. Once we found that we couldn't do that, we got beyond that capability, we built ourselves shelters, be that simple shade or more sophisticated buildings as we've sort of evolved as a civilization. It's only really in the last 100 years where we've had air conditioning.
Yeah.
And it's made us sort of rely upon it, and we've lost a lot of our natural design. So we as human beings now think we can have any building we want anywhere in the world, and we'll sort it out with that air conditioning.
Yeah.
and I think actually what we need to do is go back to designing for the climate that we're in. So designing good shade structures to provide shade. Because again, I talked a lot about humidity and temperature. If you're stood in direct sun, you get much, much hotter. It's much, much harder to regulate your temperature. So making very, very good shade structures, making use of breeze, so designing stadia so you have the right amount of air movement in that stadium and it's not completely stagnant.
Yeah.
By looking at where do you locate your venues? Are they in a very open site? Or are they in an urban site? We know about the urban heat island. We know that cities hold on to heat due to all the concrete. I've done a lot of work on existing sports venues, and where they're built from concrete, that concrete heats up throughout the day. So it absorbs all the sun's energy. And even if you then have a match at 7 p.m. when it's dark, you can have concrete that's at 40 or 50 degrees C to the touch because it's absorbed all that heat, which means it's re-radiating all that heat onto the spectators, which is not creating a great environment for the spectators watching all this sport. So for me, it's about really designing thoughtfully and designing for the location and climate that we're going to be in. And it's really about scheduling sensibly. The Olympics doesn't have to take place in the summer if we want to have it in all of these global climates.
Yeah, I guess today as well, it doesn't necessarily have to be all in the same place either. In the past, it's been about having places so that people can come from all over the world and watch the sport and stuff. But we have to now start thinking about maybe spreading those out. And if people want to watch them, they'll have to travel maybe to some of these locations. So we've got all of that to balance out as well, I suppose.
Absolutely. I mean, there are certain sports that never happen in the main Olympic city, things like sailing, the equestrian is often in different locations. And we have to think as well about these sports where the marathon, that takes place outside of a sports venue. So again, that's taking place within a city typically, or the road cycling will either take place in a city or we often see it in sort of mountainous locations. So that, again, every single sport has a different set of needs. And I think it's a combination of the sports governing bodies taking a lead in the way that FIFA has, combined with us as engineers, combined with the overall event organisers and the city, the host cities, to come up with the best way to run each sport. Because as well as it being a risk to athletes, we also just want the sport to be incredible. So there's a lot of report. Again, football probably has the most research. Even at that 29.4, the game is slower because the athletes aren't able to perform at their peak. So although they're considered safe, or a judgment has been made that it's a thermally safe environment, it's not an exciting environment. It's not the best game of football you've ever watched, which is what we want.
Yeah. Technology and engineers, they're clearly playing a huge role in preparing the facilities, particularly for the next games coming up, the US and Australia. What kind of solutions might we be seeing develop between now with the Paris Games and those games in the future?
So Brisbane has the luxury that, as I mentioned, it's a winter games in effect, because we'll be in the southern hemisphere. So actually Brisbane has quite an amenable climate. So I think actually there's a lot of very traditional design going to the Brisbane games, and we should see it from a thermodynamics point of view be quite low on the number of things that have to be considered. But LA, I think, will be a lot more challenging. LA has a much, much hotter climate. It's quite an urban location. So there's the urban heat island risk. So I think, again, I'm not personally involved in the LA games and how they're being developed, but I would like to see a real consideration of climate and the fluids and thermodynamics that go into a building. As I mentioned already, the wind flow, how do we put appropriate shading in? Really think about those venues in terms of those passive design strategies before we reach for air conditioning just to solve the problem quickly.
Yeah, the Americans are renowned for having quite a lot of air conditioning and air conditioned buildings. They rely on it an awful lot. So there's a lot that can be learned from existing building. I mean, we have a perfect example right in the centre of London, don't we? The Houses of Parliament was originally designed to have natural airflow. So it's not like we can't do this in big buildings that have lots of people in them. There are great examples across the world, and hopefully the Americans can prepare for that, learn from some of these experiences.
Yes, that's the hope. Fun fact, the Houses of Parliament were designed to be very, very cold because they were designed for Victorian gentlemen who wore, woolen suits with woolen undergarments. So actually they're a very, very, very cold environment as their natural design.
Oh, okay. Well, that is a fun fact. I was not aware of that. But that's really useful to know. We've got to balance the temperatures depending on the sorts of clothing and where people come from in the world. It's really quite fascinating, really.
I think clothing's one where sports have done a huge amount of work. So that is one of the technologies that's already very, very well established. And that was covered in the IMechE report, looking at sports engineering, is really looking at how clothing has progressed. Because if you think about sport, again, was traditionally played in tweed or in quite heavy materials. And now we have these incredible lightweight fabrics that really wick sweat away from the body and keep our players as cool as possible. So that's something where the sports industry has done the work and has taken it as far as they can. And people have different kits for different environments depending on what they're playing in.
Yeah. Yeah. Now, I said in my introduction that you're part of the team of IMechE members working with our policy team to look at the engineering behind sports facilities and stadia design. Without giving too much away, because I know the report is fairly imminent, can you give us kind of an insight into why this report has come about?
Absolutely. So the IMechE is really the home of sports engineering. And there was a report brought out last year which really looked at the engineering in sports. So it looked at clothing that people would wear, your very aerodynamic swimsuits. I've already mentioned the lightweight fabrics that really wick sweat away. It looked at things like bicycles and the design of paddles for canoeing, and the real engineering that goes into the equipment that is used by sports persons, along with a lot of the equipment that supports our para athletes. And that was really, really interesting. But venues were absent from that report. So it didn't look at venues. And what the Institution of Mechanical Engineers has decided to look at this year is really all of the great engineering that goes into a sports venue, and in particular the mechanical engineering. So we often think of them, they are incredible civil engineering projects. There's a huge amount of structure that holds up those cathedral-like roofs. And we felt there might not be an awareness of all of the mechanical engineering considerations that go into it. And we've touched on some of them in our conversation today around how do we create the right thermodynamic environment for the players and for the spectators. But the report also touches on a number of the safety aspects, such as how do we design it for fire and life safety so we can evacuate people very, very effectively? How do we design for acoustics so we get that real atmosphere, that winning atmosphere? And a number of other of those sorts of topics that, it was felt that perhaps people just didn't know about.
Yeah, you often, as you rightly say, you often think that these kind of facilities are all about the civil engineering, but there's a huge amount of mechanical, of electrical engineering that goes into even human factors and the ergonomics of how these buildings are built. And it's a great way to showcase what mechanical engineers are really doing in this space. So I'm quite excited to see the report, and obviously you've put a lot of work into focusing on the thermal comfort. So I look forward to reading that when it comes out. Ruth, thank you so much for coming on the podcast today. It's been a pleasure to have you, and I'm really excited to see not only what happens in the Olympics, but also how I might spot some of these things that you've talked about today as I'm watching the games in the future. So thanks very much for joining us.
Oh, no, thanks, Helen. As I said, some of my favourite topics to talk about, so I've had a fun time.
Mike Tipton, MBE, is Professor of Human and Applied Physiology at the University of Portsmouth. He has spent 40 years working in the area of thermoregulation, environmental and occupational physiology. He leads the Extreme Environments Laboratory in the School of Sport, Health and Exercise at Portsmouth, examining the physiological, pathophysiological and psychological responses to adverse environments and the selection, preparation and protection of those who enter such environments. He has authored over 750 papers, reports and books on the subject, and in April this year published The Rings of Fire, Heat Risks at the 2024 Paris Olympics, the second in this series of reports highlighting the worrying impact global warming and climate change is having on elite sports. Mike, thank you very much for joining me on this month's episode. It's a great pleasure to have you on the show. I wanted to start by asking you a little bit, sort of going back really to the previous Olympics, to the Tokyo Olympics. We saw temperatures get up to around 34 degrees C at that Games. It was just incredible temperatures. And this week in Paris alone, it's already reaching 28 degrees C and is expected to be averaging around 22, with humidity peaking out at around 77%. It's only likely to get hotter during these games when they actually start. So is this the norm now? Should this be what we expect for the Olympics?
Yes, I think so. I mean, it's all to do with probabilities, Helen, as you know, and there's been some interesting comparisons between the Paris Olympics of 1924 and the Paris Olympics of 2024, where there's something like between 6 to 10 times greater probability of there being a significant heat wave during the period of the Olympics. Now, the average temperatures hide the real dangers, which are the great swings we're seeing in our environment. You see that with flooding, with cold snaps, and with heat waves. And I know that, extremely hot summers are now 10 times more likely because of climate change. And when we talk about a heat wave in Paris, only a couple of years ago, they had one which quite easily pushes the temperature into the 40s.
Yeah.
Now, as you rightly point out, and as the engineers will know, in terms of exchanging heat with the environment, it's not just a matter of temperature. There's different types of temperature. There's dry bulb temperature, which is the absolute temperature that you hear mostly on the weather forecast. There's also solar load, which can be as much as 1,000 watts per meter squared in direct sunlight. Yeah. There's also water vapor pressure, which we commonly call, slightly incorrectly, but it doesn't matter, and relative humidity. And so when the humidity goes up, or when the water vapor pressure in the environment goes up, your chance of losing heat by sweating is diminished. And of course, once air temperature gets above mean skin temperature, so into the mid-30s, your only route of heat loss, because it's not temperature dependent, is by the evaporation of sweat.
Yeah.
And I emphasize the evaporation of sweat because producing sweat does nothing for you. It has to evaporate. The latent heat of vaporization, as it evaporates off the surface of the skin, cools the skin, which then cools the blood supply and then the body. So, once we get into those 30s and high 30s, then you are very dependent on levels of water vapor in the environment and humidity and your ability to lose heat by evaporation. And so that drives a lot of the innovations and including engineering and technological innovations to try and make sure that you don't inhibit that route of heat loss. So, the short answer to your question is, it's going to be the norm, and heat waves are going to be much more likely. And so now we have to look at what's doable in a summer event where the temperature is, could be in the 40s rather than in the 20s.
Yeah, indeed. And clearly these increasing temperatures are going to affect our elite athletes, even those that come from naturally hot countries, of course. What kind of effects do increased temperatures have on their performance? You've touched on it a little bit there, but what are the long-term effects that it's going to have on their bodies?
So I think it's important to recognize that it's not just the elite athletes that are going to have a problem. At the Tokyo Olympics, there were 50 cases of exertional heat illness. So as you get hotter, there are different types of heat illness. You start off with, fairly mild things like cramps and fainting and headaches, and then you move into heat exhaustion. So you can no longer function because you're exhausted. And then as body temperature increases and gets sort of 40.4, 40.5, you're now in the area where you could be suffering heat stroke. And that's a major medical emergency. But in the Tokyo Olympics, there were 50 cases of exertional heat illness. So people getting hot because they were exercising. That was 14% occurred in the marathon and the race walking competitions. A total of 18% of the athletes and non-athletes were treated at the clinics for heat illness. And I emphasize the non-athletes because this is not just a challenge for elite athletes, it's also a challenge for officials who tend to be older, less fit, but still having to run around on a football pitch to referee, for example. It's also people who are even less fit, and we're more and more of us are rather too sedentary, sitting in the heat for the day, becoming dehydrated and standing up and finding that's when they have their cardiovascular issue. So it's across the board. Now, obviously, if you're doing a sport like race walking or marathon or triathlon, 80% of the energy you consume is released as heat. So you've not got just an external heat load to deal with. You've also got an internal heat load, which can be, a couple of kilowatts. If you stop all the heat, you can do this very simple calculation in terms of heat storage. If you stop all the heat leaving a human body, and you come close to it when you put people into things like nuclear, biological, chemical protective clothing or, heavy clothing, which sometimes people wear in events like horse riding or in fencing. But if you stop all the heat leaving the body and you ask people to exercise moderately, they'll be at a level of incapacitation from heat in about 20 minutes. And we spent a lot of our work dealing with groups like firefighters and bomb disposal and people like that. But it applies equally to athletes. So it's a relatively quick way of heating the body to a level that is quite dangerous. So yes, absolutely, people doing those kind of events. But also in terms of not so much the risk to health, which has always been underestimated from a thermal perspective. Going back centuries, the athletes and coaches always worried about nutrition and training and didn't pay much attention to temperature. But now, for the first time really in the last 10 or 15 years, they're starting to realize that, you get your temperature preparation wrong, then it's not just a challenge to your performance, it's a challenge to your life. But even the sports that are static can be the heat associated with some of these environments where, you start to sweat, you're vasodilated, you've got to bead of sweat running down your brow and down your cheek, and you're trying to do something like archery or you're trying to do something like pistol shooting where the margin of error is tenths of millimeters. Heat can have an impact on that performance as well, just simply by changing mood, increasing irritability, distraction. So, it's a problem. And in terms of the long term, I mean, the pathophysiology of heat stroke is, it's not nice. Multi-organ failure, protein denaturing, central nervous system issues. Generally, if it's caused by being overwhelmed by the environment or exercising in the environment, then there shouldn't be necessarily any long-term consequences. Are you more likely to get a heat stroke again if you've already had one? And the answer to that is, well, yes, if you get into the same situation, but no, if you do things better the next time round. So if you don't exercise so hard in the heat, if you prepare better and are heat acclimatized, if you've, if you've got fitter. However, but if you go back into the same situation in the same state, the outcome is likely to be the same. There are some individuals who have a genetic proclivity to overheating, have malignant hypothermia, but they've normally are not, in the elite cohort of athletes that we're talking about here.
Yeah, it's an interesting area to think about because, as you said, it's not just the athletes that are taking part, but also the people watching the games, the people who are sitting in the stands are equally going to be affected by these increased temperatures during the games, and we've got to look out for the spectators as much as we have for the athletes themselves.
Yeah, no, as I say, the spectators and the officials, particularly in certain sports, that are required to do quite a lot of work, but they're not going to be at the same level of fitness. They're going to be older, and as you get older, your thermoregulatory capability diminishes. But as I say, from the Tokyo Olympics, there were a significant number of people who were not athletes, who were non-athletes, treated for heat-related illnesses. So that underlines the point that, yes, the elite athletes are producing a lot of heat and most likely to get a challenge from the heat, but they're also the individuals who are most likely to be able to deal with that challenge.
Yeah, of course. That brings me nicely on to your research particularly, and I'm very keen to ask you about that and also about the report that you just put out called The Ring of Fire. What was your motivation for producing that report, and what are you hoping the outcomes of it will be?
Starting with the report, that's prior to the Tokyo Olympics, we produced a similar report, Rings of Fire, Heat Risks of the Tokyo Olympics. And we work with particularly the British Association for Sustainability in Sport with these reports. And they have several aims initially. One is to obviously identify the risks and promote safety in these environments. So it's to one level, we're speaking to the federations that run the different sports and saying, look, be aware that 1.82 degree increase in average temperature may not sound very much, but that's not the issue. The issue is if you have a heat wave that week, which you, by the way, have had in Paris that week, and now you're asking people to run a marathon in 40 degrees, what are you going to do about it? And by the way, here are some of the things that you can do about it.
Yeah.
So it's to raise the issue, but it's also very important that it raises the issue of climate change. And obviously, the British Association for Sustainability in Sport is very into climate change, as are we in a lot of the work that we do. And what we want people to realise, and sports fans, and there are lots of sports fans who support sports that will be impacted. One of the other reports we produced was Hit for Six, which was the impact of climate change on cricket. And people sort of say, well, cricket, that's kind of strange sport to do, but it's the second most watched sport on the planet.
Right.
And it's played in a lot of areas which are, under great threat from climate change. When you look at Bangladesh and Pakistan and India and Australia. And so the aim was to say, listen, sports fans, if you want to see a spectacle that is as good as it's been and not one that's been impaired by the temperature, where people have to stop, where events are changed, cancelled, because of not just temperature, but also humidity, because of pollution, then, you need to lobby along with us to mitigate climate change. So it's to try to get people to understand that this is affecting all aspects of their life, and particularly their favourite pastime, which happens to be watching sport.
Yeah.
And we're already seeing it. We're already seeing sports events being changed in terms of where they're located, what time of day they start, how they operate, when they have to be cancelled. I've been involved in triathlons where they've had to reduce the distances. We've had tennis now that will have breaks when it gets hot, or events cancelled. And so this report had lots of different objectives when it started, and people can go online and get the report freely. But the recommendations were to make sure that we're doing the very best we can in terms of communicating between sports, communicating athletes with their concerns. I mean, we've had lots of concerns from particularly tennis players talking about, there'll be somebody who'll die on court, and people have had to retire from tennis events because of overheating. And also we're asking in the recommendations of that report for smart scheduling, make sure you keep athletes safe, commit to collaboration between sports, and give some thought to where you get your sponsorship from. If you're being sponsored by groups that are fossil fuel related groups, then you're kind of compounding the problem to some extent.
Yeah.
So that's a lot of ambition for that report, but it has generated a lot of media interest and a lot of sports. To be fair, given that, as I say, 10 or 20 years ago, very few sports even considered this. More and more sports are now considering introducing some kind of mitigation. It's not the same across the board, and to some extent you wouldn't expect it to be the same across the board because different sports have different challenges.
Yeah. In
fact, there was a paper published just this week which people can have a look at in terms of the heat-related risks. And of the sports that go on in the Olympics, there are 15 of them that have been identified as having a high or very high risk of heat stress. And now, one of them doesn't have any heat-related policy. 3 don't specify the measurement of the parameters they want in order to stop the event or amend the event. And 11 mention the use of thermal indices. And engineers will be quite into thermal indices. These are aspects of the environment that you take to come up with some idea of the potential for heat stress. I've already mentioned them in terms of radiant heat, humidity or water vapor pressure and temperature. Some of the sports just use one of those measures. Others are using 3. But the problem is most of those measures were engineered on the basis of the military. So they don't account for things like intermittent activity. They don't account for clothing. They don't account for a competitive environment. So there's definitely work to be done collaborating between technology, engineering and physiology to produce a more elite sports specific index for altering what happens in sports.
Yeah, it sounds like there's a great opportunity here as well to bring those bodies, as you've just mentioned, together to actually create some kind of standard by which some of these things can be measured. Because it sounds like that there isn't a specific standard or something that the sporting bodies can work to. So there's quite an opportunity here, I think, isn't there, for the engineering community to look at creating something like that? I think there is. I mean, there's the one that's out there that's used most is the wet bulb globe temperature, WBGT. Yeah.
But if you look at the history of it, back in the 50s and the way it was evolved, it wasn't evolved for elite sports. It was evolved for the military, working and operating in hot environments. And it's okay, it's going in the right direction, but it needs more work for the kind of environments we're talking about and the kind of clothing and the nature of the physical activity.
Yeah.
So, that's one area where there definitely is. I mean, as you know, I'm a real believer in bringing together these different disciplines with these kind of issues. And the biggest issue, as we already discussed, is climate change. And I'm amazed that we don't have groupings that bring together engineers, physiologists, behavioral psychologists, architects, the kind of botanists, the kind of groups you're going to need if you're going to optimize your approach to the problem of the urban environment, the indoor environment, cooling different spaces. The other area where I think there's more opportunity for engineers is in the mitigation strategies. So, it's not just saying, okay, there's a problem, we've got to change the event, we've got to cancel the event, we've got to move when we have it. But also, there's quite a lot of technology now going into cooling and looking at how to cool athletes. And that ranges from things like reassessing work-rest schedules in intermittent sports. How long can you allow somebody to exercise? Should we be breaking a sports performance into 4 quarters rather than 2 halves?
Yeah.
Then there's things like cooling strategies, cooling techniques, whether that be fanning, air conditioning, water perfused suits, air perfused suits. Hand immersion is a very good way of cooling people using the physiology of the body. So the best current forms of cooling take the physiology of the body and then apply an engineering solution to it. So you get the body to deliver the heat to the surface of the skin, and then some form of cooling, mild cooling actually, will just gently take that heat away. And that's a much better way of removing heat from the body, a much more effective and efficient way than putting the body into a very cold environment and it all shutting down, the physiology working against you, and you trying to suck out the heat by conduction. There's loads of potential for collaboration.
Yeah, I was going to ask you a little bit more about that, about some of the tools and the technologies that athletes are using now to prepare themselves for these kind of increased temperatures, and also the mitigations that they're implementing to protect their body. You mentioned there a few ideas, but what sorts of technologies are out there right now?
There are things like water perfused suits, ice vests, air perfused suits, and a lot of these have got a military background from particularly fast jet pilots, etc. There's fanning, there's regional cooling such as hand immersion. We've done work looking at wetting the surface cooling with combinations of ethanol and menthol. Menthol stimulates the cold receptors and makes you feel cool.
Yeah.
So it can increase your thermal comfort and reduce your stress associated with that. And of course, an ethanol component will evaporate more quickly and more efficiently than water. So it has a greater cooling capacity, although the duration is shorter because it all evaporates quickly.
Yeah.
I mean, again, you have to then say, okay, well, it depends on the circumstance of your sport. If you can continually apply a menthol ethanol solution to the clothing, then that's fine. If you can only do it once an hour, then it's probably not that good, in that you'll get a cooling period and then nothing because it'll have all evaporated. So, because you're talking about 45 or so sports, there's not one solution that applies in all sports. And the kind of solution that you might have for something like pistol shooting or archery, is likely to be quite different to that you would apply to rowing.
Yes.
I mean, in the shooting environment, you're trying desperately to maintain comfort. And we know, for example, that fanning the face is a really good way of maintaining thermal comfort, but does very little for your heat extraction.
Okay.
Because the receptors we have on the face are, if you give somebody a fan, they don't fan their arm or their thigh or their chest, they'll fan their face. And so if you can get air movement over the face, you can maintain performance better than you can with, for example, hand immersion or some other form or some other intervention. So it's very much horses for courses. And actually, speaking of horses, the very first question I ever got, which was back in the Los Angeles Olympics, was how to keep the horses cool. It was actually nothing to do. Nobody was bothered about the humans. They were worried about the horses getting too hot in Los Angeles. And that's when we introduced shaded corrals with misting and fanning. So, I'm just going to say, because part of your question was say, well, what do we do specifically? Well, we look at these different interventions and assess them. We make ideas and we work with engineers and companies to sort of come up with new innovation. But in terms of the athletes, the thing we do most is we assess them for their individual, because at this level, at elite level, you have to work at the individual level. You can't take a generic approach, because Johnny Brownlee's performance in the heat is quite different from Alex Ye's, and we're talking triathlon, of course. And so what we'll do is we've introduced with what was the English Institute of Sport, now the UK Sports Institute, a standard heat exposure. So everybody gets exposed to heat, and from that, you can work out those that are naturally perform better. We know right from work right back in the gold mines of South Africa that, there are a percentage of people who are naturally more tolerant of heat. There are a percentage of people who are naturally intolerant of heat. And of course, you need to assess that, because the people that you have who are more intolerant need, and actually somebody like Johnny Brownlee is one of them, just needs more intervention in order to make him able to perform close to his best. And the biggest intervention that we deal with physiologically is heat acclimatization.
Right.
So you can significantly change both the physiological and psychophysiological status of somebody by getting them heat acclimatized, which is what most sports are doing now in holding camps prior to the Olympics. So I know triathlon are out at a holding camp near Bordeaux, and they'll be trying to get used to the heat. You can do it in in a climatic chamber, and often that's better because it's much more controlled and you can guarantee temperatures. But quite a lot of that's been going on, and now they're getting used to the environment and the time zone change and et cetera, et cetera.
Sure, yeah. Let's talk a little bit about the future then. The next two Olympics are due to be held in the US and Australia, respectively. I guess while Brisbane's going to be hosting in their winter time, it's less likely to be excessive heat. But even so, by the time we get to Brisbane, according to the science behind the temperature global warming, we could see at least a 1.5 to 2 degree increase in global temperatures. What kind of changes will sporting bodies particularly need to make to ensure that the athletes remain safe?
Well, I mean, I think we've touched on some of them. I mean, I think there'll be some consideration to where and when the most high risk events are, located. There may be some consideration to what time of year the whole Olympics. I mean, maybe it should be an autumn, spring event rather than a midsummer event. I think there'll be a big increase in things like wearable technologies.
Yeah.
At the moment, I mean, we do quite a lot of work with different forms of wearable technology, mostly in their evaluation and assessment. And as with all things at the start of a voyage, the claims made are somewhat more exaggerated than the actual performance in terms of what they deliver. But I think there's going to be a significant increase. Now, whether that wearable technology where you're looking at, surrogate measures of deep body temperature, when you're looking at oxygenation, you're looking at heart rate, metabolism, whether or not they ever get written into some kind of safety procedure, i.e., if this gets to that, then that athlete should be withdrawn. I think that's going to be a really interesting ethical, moral area going forward, because if you're going to remove somebody, and these kind of events now are people's livelihood. I mean, this is not amateur in that respect anymore. And if you say to somebody, okay, you're 20K into a 42K marathon, and our wearable technology is suggesting that you need to stop, you better make sure that wearable technology is accurate, and you better make sure that it's calibrated for that individual, because we know enough about how humans respond. I can tell you there's an enormous variability in people. We've already touched on it in terms of responses to heat, but you can say exactly the same for altitude, for cold. And so, quite a lot of the wearable technology, the first thing you need to do to make sure that it's of real use is to calibrate it to yourself. And, all of these issues are to come down the line. There'll also be respiratory protective equipment in terms of pollution. It's already being produced. We've worked with groups like Dyson to look at running masks that filter the air, not so much for the UK environment, but more for the sort of Far Eastern environment. There'll be developments in smart clothing. I mean, the best clothing to wear in the heat is skin. As soon as you put something over the skin, I mean, with the exception of sunburn, but when you put something over the skin, you've immediately put a barrier between the body and the environment, and you're diminishing the efficiency of evaporative cooling. But again, it depends on the environment. If we start getting regularly environments where heat is being gained from the environment significantly, then that changes the design of the clothing in terms of making it more protective, but enabling good vapor permeability and good vapor transfer for cooling. So these are really interesting questions. But I think the big areas will be smart clothing and wearable technologies.
So it sounds like the engineering community have got a big opportunity to look at sensing, material science, and all kinds of areas that could really have an impact on the athletes of the future, which sounds really quite exciting.
Yeah, and as I say, the way that's best addressed is by collaboration. And so in that, I mean, just taking something like smart materials, you'd want an engineer, a physiologist, clothing technologist, a clothing designer, and some athletes to try it with. So, interesting times.
Yeah, absolutely. Mike, thank you very much for joining me on today's podcast. It's been really insightful to understand what the future holds, not just for our athletes, but also for the engineering community as well. So thank you very much.
My pleasure. Thank you.
That's all for this month. In next month's episode, we will be exploring the mind-boggling world of quantum engineering and how engineers are turning physics theory into commercial opportunity. You've been listening to Impulse to Innovation, the Institution of Mechanical Engineers podcast. Thanks for listening. We'd love to hear from you, so if you'd like to share any news or any feedback with us, then please email us podcast@imeche.org. All the information on this episode can be found in the episode notes.